All right, so if you've ever tried to build a trading strategy, you know the real struggle, right? It's not just about making it look good on past data. The real trick is making it actually work in the future. Today, we're going to dive into how to escape that trap of the past and build strategies that are genuinely ready for whatever comes next. I mean, it's a terrifying thought, isn't it? You spend months tweaking, finding those perfect parameters, your backtest looks absolutely incredible, and you think, I'm ready to take on the markets. But what if that so-called perfection is actually a lie? What if it's a trap? That's the huge problem we're going to unpack right now. And yeah, that trap has a name. It's called overfitting. And let me tell you, it's one of the sneakiest, most dangerous problems in all of systematic trading. It's this hidden flaw that can take a strategy that looks like a work of genius and turn it into an absolute disaster. So what is it exactly? Well, overfitting is what happens when your model gets a little too smart for its own good. It's been tuned so perfectly to past data that it doesn't just learn the real patterns, it also memorizes all the random noise, all the pure luck. So you end up with a model that's a genius at explaining the past, but it's totally useless, completely clueless when it comes to predicting the future. You know, there's a perfect analogy for this: the cramming student. Picture this. A student gets a copy of last year's exam. They don't learn the subject. They just memorize every single answer, word for word. Of course, they're going to ace that one practice test, right? But what happens on the day of the real exam? New questions, different problems, and they're totally lost. They fail. That is overfitting in a nutshell. Okay, so people have been wrestling with this problem for ages. And, we've come up with a few common solutions, but here's the kicker. Most of them are deeply flawed. Let's take a look at why they just don't cut it. So what's the first thing everyone thinks of? Just use more data? I mean, it seems super logical, doesn't it? The more history you have, the more confident you should be, but it's just not that simple. And this gets us to what the source material calls the data paradox. See, on one hand, if you have too little data, that's like the classic recipe for overfitting, no question. But on the other hand, markets change. Think about it. Regulations shift, technology explodes, the way people trade is completely different now. Data from, say, 20 or 30 years ago might be totally irrelevant, and throwing it into your model could actually hurt you, not help you. All right, so if more data isn't the silver bullet, what about some super elegant math? These really precise analytical models. They look amazing on paper, just beautiful. But there's a huge catch. To get the math to actually work, you have to make these wildly unrealistic assumptions, like all investors are rational or price movements are predictable. Come on, we all know the real world is messy and chaotic. The second one of those models touches reality, it just collapses like a house of cards. So it really feels like we're stuck between a rock and a hard place, right? Too little data? Bad. Too much data? Also bad. And pure math? Way too simple. It's a total trap. But what if there is a way out? What if there's a method that lets us completely break free from the shackles of history? And this is where things get really interesting. This is where the breakthrough happens. We're talking about the world of simulations. It's a completely different way of thinking, a powerful alternative that just reframes the entire problem. So how in the world does this work? Simple. Instead of being stuck with the one single path that history actually took, we're going to create our own realities, thousands of them. We generate thousands of alternative market histories, plausible futures that could have happened based on how the market actually behaves. They just didn't. And that right there is where we find our edge. The best way to think about this is like a flight simulator for your strategy. Seriously, a pilot doesn't just practice landing on a sunny day with no wind, right? No way. They jump in the simulator and face engine failures, crazy storms, intense crosswinds, all kinds of stuff they hope they'll never see, but they absolutely have to be ready for. Well, that's exactly what simulation does for your trading strategy. And this really gets to the crucial difference. See, traditional backtesting, it's all about optimizing for the best outcome on that one single historical path. But simulation? It's totally different. It models the underlying market behavior, the guts of the market, its volatility, its trends. Then it creates new paths from that behavior. And because you're not just curve fitting to a bunch of old outcomes, you slash the risk of overfitting. It's a game changer. Okay, so let's get practical. How does this actually work? Because this isn't just some abstract, theoretical idea. It's a real, structured process that you can actually use to build way more robust strategies. So here's the workflow, step by step. First, you model the historical market behavior. You capture its personality, basically. Second, you use that model to generate thousands of new synthetic worlds, brand new price paths. Third, and listen up, this is the key part, you find the strategy settings that work best on average across all those different worlds, not just one. And finally, you take those winning parameters and you do one last check against the real historical data. But, and this is absolutely critical, you don't get to tune it anymore. It's a final exam, not another practice session. What this all boils down to is a massive shift in your mindset, a huge one. You're not chasing that 1 in a million perfect score on that one historical path anymore. That's a fool's errand. Instead, your goal becomes finding a strategy that's tough, that's robust enough to survive and hopefully even thrive across thousands of different possible futures. And this brings us to the big takeaway, the core idea behind this entire approach. And you know what? It's actually pretty simple, but it is incredibly powerful. I mean, what we're really talking about is a complete transformation of the whole process. We're leaving behind what's basically just fancy curve fitting, just connecting the dots of the past. And we're moving into the world of what you could call probabilistic engineering. We are engineering a solution that's designed from the ground up to handle a future we know is uncertain. And there's a quote from the source material that just sums this up perfectly. The objective is no longer to find the best parameters for the past, but to find strategies that survive across many plausible futures. It's not about mastering what happened, it's about building something that can survive whatever happens next. And if there's one thing you take away from all this, let it be this. That perfect, super precise strategy that only worked on one historical timeline, it's fragile. It's a glass cannon. But the resilient strategy, the one that's been battle-tested against thousands of different worlds, that's the one that lasts. Because when you get right down to it, in the chaotic, unpredictable world of the markets, resilience beats precision every single time.